Now we reach one more threshold of complexity in this course. It's the seventh of the 8 thresholds in this course. And what I want to do in this lecture, as I did with the previous threshold, the threshold on the borderline between non-human and human, is to define the nature of that threshold very, very clearly indeed. And the threshold, of course, is the appearance of agriculture about 10,000 years ago. But I want to remind you that there are some striking parallels between all of these thresholds, and in fact some particularly striking parallels between this threshold and an earlier threshold, that of star formation. Do you remember how we got from the early universe to stars? We had an expanding universe within which all the basic units of matter were fairly similar. Matter consisted basically of hydrogen and helium atoms. Then gravity began to draw these clumps of matter into denser communities within which pressure began to rise and then temperature. And then eventually, at the critical temperature of 10 million degrees, fusion reactions began at the center of these clouds and stars lit up. And suddenly, you had the universe arranged in a very different way, with powerful hotspots dotted throughout it, a new form of complexity. Now, I want to sort of explore some of the parallels with human history. Paleolithic communities, with their astonishing ability to adapt to new environments through the capacity for collective learning, as I described in the last lecture, provide the equivalent of the Big Bang as their range expanded to reach across most of the Earth. Now, of course, Paleolithic communities were nothing like as simple as those primeval clouds of hydrogen and helium. As humans spread through the smaller universe of our planet, they were developing more diverse and in some cases more powerful ways of dealing with their environments. Nevertheless, their basic units, these small kin-based nomadic groups into which humans were organized throughout the Paleolithic, seem not to have changed fundamentally. Then, from about 11,000 years ago, a series of new technologies that we will label agriculture began to bring humans together into larger and denser communities, just as gravity had once drawn huge clouds of hydrogen and helium together. As agriculture increased the population density of human communities, they began to draw in other communities through a social equivalent of gravity, just as towns suck in rural migrants today. And in this way, agriculture increased the pressure within human communities and the number and even sometimes the violence of encounters that occurred between individuals, until eventually, in a parallel to fusion reactions, towns and cities appear quite suddenly, as we'll see, in a striking parallel with the lighting up of stars. In this way, agriculture began to create regions of greater density across the surface of the Earth, and it was in and around these hotspots, using the energy flows that they generated, that new forms of complexity would eventually arise in human history. And eventually these emerging hotspots would create a more complicated and diverse geography of complexity within human history. Now we start describing the build-up of these new forms of social complexity. The early stage is a bit like the collapse of a solar nebula. Now, having mentioned this parallel, let me say immediately, I don't want to make too much of such parallels. In the present state of knowledge, it would be a mistake to do so. But I cannot resist the temptation to think that the similarities are not entirely accidental, and they may arise from the very nature of complexity itself. And meanwhile, of course, they're exactly the sort of thing that you expect to see in a course like this, which compares change across many, many disciplines. And they may, if nothing else, help us to think about how these thresholds occurred. If so, they will have fulfilled a useful function within this course. Okay, back to agriculture. Threshold 7 introduces a new type of technology, agriculture, or rather a whole suite of new technologies. Why did the appearance of agriculture set human history off in entirely new directions? It did so by increasing human control of food, energy, and other resources. So, like gravity, it generated denser communities and larger energy flows. And that is why it provided the foundation for new forms of complexity. And that's why we regard the emergence of agriculture as a major transition in this course. So in this lecture, I want to define the nature of agriculture, give a very brief chronology for the appearance of agricultural societies, and discuss the impact of agriculture on human history. Let's begin with some chronology and periodization again. I want to define the early agrarian era. The appearance of agriculture marks the appearance of what I'll call the early agrarian era. This is the first of two subdivisions of the agrarian era, and we've seen the agrarian era is one of the great divisions in this course. The second subdivision of the agrarian era I'll call the later agrarian era, and it begins, at least in some parts of the world, about 5,000 years ago with the appearance of the first large cities and states. Now, the early agrarian era begins with the appearance of agriculture. So we can define it as the first era in which there were communities that supported themselves mainly from agriculture. The first era of human history in which such communities existed. Now let's look at some dates. Seen globally, seen across the entire world, the early agrarian era lasted from the appearance of agriculture more than 10,000 years ago until the appearance of the first agrarian civilizations, until cities and states appeared just over 5,000 years ago. However, in many parts of the world, agriculture appeared later, and so did agrarian civilizations. So dates for the era vary significantly in different regions. And to explain this, it might be helpful to introduce an idea that we're going to make a lot of use of later on, and that is the idea of world zones. To understand the agrarian era, it'll help to think of the entire world as divided into four major world zones, whose histories were so different that they might as well have taken place on different planets. They were zones in which history played itself out without any significant exchange between them. Now, we could have used the idea of world zones in the Paleolithic era, but we'll see it's much more useful in discussing the agrarian era. What were the four zones? They were, first, the largest and oldest, the Afro-Eurasian zone. It includes the Eurasian landmass and Africa, because of course the two continents were joined. The second in size is the American world zone. That includes both North and South America, because these two, in the last few million years, have been joined into a single landmass. The third world zone is, I'll call, Australasia. It includes Papua New Guinea for most of the last ice age. And the fourth is the Pacific, the vast archipelago of islands spread out throughout the Pacific, a world zone that is occupied only in recent millennia. So here are our four world zones. And to understand the chronology of early agriculture, we'll need this concept. So let's go back to the chronology. Agriculture evolved independently in at least 6 separate parts of the world that were scattered through 3 of these world zones. The dates I give represent current estimates, but I should remind you that work on early agriculture is flourishing, and some of these estimates could change slightly in the near future, but at present there seems to be a reasonably clear picture. But you should note that all the dates are approximate. And one more thing about dates. I'm going to give these dates as dates BP. That means before the present. This is a terminology that archaeologists use, and it's associated closely with radiometric dating. To be strict, a date BP means a date before 1950, as that was the benchmark date used when carbon-14 dating was first introduced. But for most purposes, we can ignore this wrinkle. So a date BP essentially means a date before the present. Now, the crucial thing to note is that agriculture appeared within a few thousand years in parts of the world that had little or no, or in some cases no connection with each other. That's one of the most remarkable things about it. One of the great oddities of the early history of agriculture. The earliest evidence of agriculture comes from the Fertile Crescent. This is a semicircle of land that begins along the Nile. It runs up the eastern seaboard of the Mediterranean, through Israel and Lebanon, up to the southern borders of Turkey, turns east, then runs down along the borders between Iraq and Iran. Here, agricultural villages appeared as early as 11,000 years BP. That's 11,000 years ago. Their main domesticates were wheat, barley, peas, lentils, and a few animal domesticates: sheep, goat, pig, and cattle. Agriculture may also have appeared this early in parts of the Sahara, which was then wetter than today. So that's our first date, about 11,000 years ago, for the first appearance, the first clear evidence of agriculture. By 9,000, somewhere between 9,000 and 6,000 years ago, there's evidence that agriculture was being practiced in Papua New Guinea. Now this, let me remind you, is in the Australasian world zone. So one of the second areas in which agriculture appears is within the Australasian world zone. It was based on taro, a root crop, on sugarcane and banana. Agriculture, we'll see, never appeared in the other parts of the Australasian world zone, only in Papua New Guinea. By 9,000 BP, some form of agriculture had almost certainly appeared also in East Asia, in China. Agriculture based on rice towards the south, on millet further north, and pigs and poultry were important in both regions. So by 9,000 BP, agriculture has appeared also in China. And by the same time, it's probably also appeared in parts of the Indian subcontinent. By 9,000 years ago, agriculture was probably well established along the Indus River in modern Pakistan. Perhaps, we're not sure about this, as a result of diffusion from Mesopotamia. And then from Pakistan, it seems to have spread to much of the rest of the Indian subcontinent. Now, the next crucial date is somewhere between 5,000 and 4,000 years ago, when we start to get evidence of agriculture based on millet and yams and African rice and cattle appearing in sub-Saharan Africa. It may also have appeared earlier in the Sahara and Sudan. At about the same time, this is about 5,000 to 4,000 years ago, agriculture appears in Mesoamerica. Now here's the first evidence of agriculture in the American world zone. Agriculture based on maize, beans, squashes, manioc, and tubers, such as potatoes, as well as small animals such as guinea pig, was present in central Mexico and in parts of the Andes region in the American world zone by 4,000 to 5,000 years ago. Then, 1,000 or 2,000 years after that, evidence appears of agriculture in parts of North America. Agriculture here is based on squashes and local crops such as sumpweed. It may have appeared independently, but it may have appeared under the influence of agricultural regions in Mesoamerica. So this is a brief outline chronology of the first appearance of agriculture. And that gives sort of beginning dates for the early agrarian era in 3 of the world zones. Now, we need to define carefully what we mean by agriculture. What is agriculture? This is one of those questions we've seen before that seems to have an obvious answer when you first ask it, but once you try and pin it down to give a precise definition, it turns out to be subtler than it seems. So defining agriculture is surprisingly tricky. What we need, I think, in this course is a definition that's not just a dictionary definition, but a definition that captures the essence of agriculture, and also can convey something of its astonishing transformative capacity. So now I'm going to try to define agriculture carefully, as in an earlier lecture I tried to define collective learning, precisely and carefully. This is one of those areas where the multiple perspectives of big history can be very, very helpful indeed. So let's look at biology from the perspective of a biologist. So let's look at agriculture from the perspective of a biologist. From a biologist's point of view, agriculture can be regarded as an intense form of symbiosis. Now, we've met symbiosis before. We've seen that in the biological realm, cooperation is in many ways as common as competition. And we've also seen that cooperation can take many different forms. Essentially, what we mean is that two quite separate species start living close together in ways that advantage both species. Now, let's describe different forms of symbiosis. Mutualism is a type of symbiosis involving relations between species that seem to benefit both species. We can think of it, if you like, as a sort of fairly equal form of symbiosis. For example, there's a type of ant known as a honeypot ant. Honeypot ants keep herds of aphids. They protect them, they help them reproduce, and they also extract honeydew by stroking them with their antennae. Now, it's clear what advantage the ants get from this. They get food, honeydew, just as we milk cattle. But what benefit do the aphids get? Why should we call this mutualism? Well, they lose a lot of freedom, but they're protected and they're helped to reproduce. So the species as a whole does pretty well. Now, there are many other examples of mutualism, including, for example, one of the most important forms of mutualism that we know of, the relationship between flowering plants and pollinators, such as bees and birds. This is a fantastically important form of mutualism for modern agriculture. Other forms of symbiosis, such as parasitism, seem to benefit one organism much more than the other. Nevertheless, in all durable forms of symbiosis, both sides must get some benefit, because if one side is seriously damaged, eventually it will cease to exist and the relationship will collapse, harming both partners. So we can think of symbiosis on a scale running from mutualism, a fairly equal relationship, to parasitism, in which one side clearly seems to be getting more benefit than the other. Okay, with those ideas in mind, here's a preliminary definition of agriculture. Agriculture, I'll suggest, is a symbiotic relationship between humans and the species that we call domesticates. And it's a relationship that benefits both sides. So let me say that again. Agriculture is a symbiotic relationship between humans and the species we call domesticates. And it's a relationship from which both sides benefit. So let's look at the cost-benefit analysis of agriculture. How do the domesticates benefit? Well, they benefit from human protection because humans look after them and protect them, and humans do that because humans need them. And that's why their populations are so large. Václav Smil proposes an interesting way of thinking about this. He suggests a way of estimating the total biomass of domesticated and wild mammals to see which has benefited most. In effect, what he does is he imagines that we take all these organisms, we boil them down until all we've got left is carbon. So he reduces them notionally to a biomass in carbon. Now, this is what happens when he calculates this out. He estimates that the biomass of all domesticated mammals, when reduced to carbon, is now about 120 million tons. The biomass of wild mammals on Earth today is only about 5 million tons. Now, immediately that gives a very striking demonstration of the evolutionary benefits to domesticated animals of being domesticates. Now, many domesticates could no longer survive without human help. This relationship has become so close that it's a matter of life and death, certainly for the domesticates. Maize can't seed itself. Domestic sheep are now pretty helpless against predators without human protection. How do humans benefit? Humans benefit because humans receive food and other services from their domesticates. If maize or sheep were to vanish overnight, millions of humans would suffer serious starvation. We are very dependent on this relationship too. Now, once you get species that are this dependent on each other, what tends to happen is that they, in the language of the biologists, they co-evolve. As one changes, so do the other. So what's happened is that we and our domesticates have co-evolved. We've slowly changed, sort of in lockstep with each other. But the co-evolution takes different forms for humans and domesticates. Domesticates have mostly changed genetically. Domestic cattle, for example, are smaller and more tractable than their wild ancestor, the fearsome aurochs. Aurochs survived until the 18th century, incidentally. These were seriously fierce, dangerous animals. Or compare another example. Compare wild and domestic sheep. The wild relatives of sheep, such as the thin horns of the northwestern United States, are intelligent, athletic, cunning. They're well able to defend themselves against, or to escape at least, from some pretty ferocious predators. Frankly, they're pretty magnificent beasts. Now, can we say the same of their domestic cousins? I don't would be too hard on domestic sheep, but I don't think so. They are, frankly, stupid, slow, fat, and more or less incapable of defending themselves. Why? Why should they evolve to become stupid, fat, and incapable of defending themselves? And the answer is because that makes them meatier, woollier, easier to manage, and therefore more attractive to humans who protect them and look after them. So both sides benefit. But while the domesticates have changed genetically, humans have mostly changed culturally. In a sense, therefore, we can say that humans, too, have been domesticated. Certainly, from the point of view of surviving foragers, the life of farmers often seems little better than that of domestic cattle. Farmers are genetically more or less identical to their Paleolithic ancestors, but they have very different life ways. They've evolved culturally rather than genetically. However, I should add that even humans have undergone some genetic changes. For example, genes allowing adult humans to digest raw milk seem to have spread very rapidly amongst farmers that also depend quite heavily on the herding of livestock and that milk their livestock. So, in summary, we've been discussing what agriculture is. And I've argued it's a symbiotic relationship in which humans help favored species to reproduce in return for food and other services. The domesticates evolve genetically, humans evolve culturally. Now let's ask why agriculture had such a transformative impact. Why does it count as a fundamental threshold in this course? Now here I'm going to offer a very general answer. The more detailed answer we're going to see in the course of subsequent lectures. Agriculture transformed human history, above all, by increasing human control of energy and resources. Now we've seen that humans, by their very nature, are fantastically good at finding new ways of getting energy and resources. Agriculture marks a very sharp acceleration in this process. It's a sort of energy bonanza. It generated massive new energy flows. How? What happens with agriculture? Well, here's a way of describing agriculture that may convey this. What farmers or agriculturalists do is this. They clear away species that they can't use. Now, we call these species weeds or pests, but of course, in an objective sense, they have as much right to exist as anyone else. That's simply, we use those terms because we can't use them, we don't want them. So you get rid of them, you remove them, you hunt them down, you move them from the soil. And we do that to increase the production of those plants or animals that we can use, which we call domesticates. Now, this activity, removing species we don't like, increasing production of those we like, very often reduces total biological productivity. But what it does for us is it channels more of the sun's energy captured through photosynthesis into species that we can use. The result is an increase in our species' share of biospheric resources. I hope you see that agriculture seen like this counts as a successful grab for more energy by a single species. We're increasing the amount of biospheric energy and resources that come our way. Now, another way of putting this is to say that agriculture implies intensification. I described the extensive technologies of the Paleolithic era and how they allowed human populations to spread to new regions without ever increasing the density of human populations. The intensive technologies of the agrarian era work in a very different way. What they do is they allow more humans to live in a given area. This is how agriculture increased the social pressure within early human communities. It brought people together in larger and denser communities where they encountered each other more frequently and, like atoms in those early solar nebulae, collided with each other more frequently. It's as if the social temperature began to rise as the social pressure rose. Larger, denser communities then began to pose new problems, but they also created new opportunities. Human populations supplied with more energy began to grow rapidly. Human population really begins to take off with the appearance of agriculture. So humans get more energy and resources, and that supports population growth. Our species, along with the domesticates that we're supporting, begins to grow in numbers. Human populations become larger. Even the earliest forms of farming could support something like 50 to 100 times as many people as foraging technologies could from the same area. So this is a massive increase in the number of people that can be supported from a given area of land. Larger, denser communities in turn generate new forms of power and hierarchy, and they stimulate collective learning and innovation. After all, living in a permanent community of 10,000 people is a very different thing from living in a mobile community of just 10 or 20 people. More ideas are being exchanged. This increases the synergy of collective learning, but also in the larger community, it was impossible just to relate on personal terms now because you don't know most people. So new rules are necessary to govern relationships between people who barely knew each other. People had to be classified in new ways so that strangers knew how to deal with each other. So in these large communities, all the rules began to change. And these changes accelerated social change, and they began to transform human societies. Niles Eldredge, Stephen Jay Gould's colleague and one of the pioneers of the theory of punctuated evolution, writes of agriculture. Agriculture represents the single most profound ecological change in the entire 3.5 billion year history of life. This is a biologist speaking, not a historian. Now, I'll leave you to decide whether this is too much of an exaggeration, but I quote him to suggest just how striking this change may appear in the eyes of a biologist who spent a lot of their career studying the evolution of life on Earth. Now, in summary, we've seen that agriculture is a symbiotic relationship between humans and animal and plant domesticates, whose effect is to increase the resources available to both sides of the relationship. By doing so, by supplying humans suddenly with a very considerable increase in energy, it allowed greater complexity, certainly among humans, who after all played the dominant role in this relationship. In this lecture, I've discussed what agriculture is and why its impact was so revolutionary. Now, with a very clear understanding of what agriculture is and why it counts as such an important threshold, we can ask the question, why? Why did agriculture appear in so many different parts of the world from about 10,000 years ago. Thank you. Now we reach one more threshold of complexity in this course. It's the 7th of the 8 thresholds in this course. And what I want to do in this lecture, as I did with the previous threshold, the threshold on the borderline between non-human and human, is to define the nature of that threshold very, very clearly indeed. And the threshold, of course, is the appearance of agriculture about 10,000 years ago. But I want to remind you that there are some striking parallels between all of these thresholds, and in fact some particularly striking parallels between this threshold and an earlier threshold, that of star formation. Do you remember how we got from the early universe to stars? We had an expanding universe within which all the basic units of matter were fairly similar. Matter consisted basically of hydrogen and helium atoms. Then gravity began to draw these clumps of matter into denser communities within which pressure began to rise and then temperature. And then eventually, at the critical temperature of 10 million degrees, fusion reactions began at the center of these clouds and stars lit up. And suddenly, you had the universe arranged in a very different way, with powerful hotspots dotted throughout it, a new form of complexity. Now, their basic units, these small, kin-based nomadic groups into which humans were organized throughout the Paleolithic, seem not to have changed fundamentally. Then, from about 11,000 years ago, a series of new technologies that we will label agriculture, began to bring humans together into larger and denser communities, just as gravity had once drawn huge clouds of hydrogen and helium together. As agriculture increased the population density of human communities, they began to draw in other communities through a social equivalent of gravity, just as towns. So I want to sort of explore some of the parallels with human history. Paleolithic communities, with their astonishing ability to adapt to new environments through the capacity for collective learning, as I described in the last lecture, provide the equivalent of the Big Bang as their range expanded to reach across most of the Earth. Now, of course, Paleolithic communities were nothing like as simple as those primeval clouds of hydrogen and helium. As humans spread through the smaller universe of our planet, they were developing more diverse and in some cases more powerful ways of dealing with their environments. Nevertheless,